Is your KitchenAid ice machine falling short, barely making ice or not making any at all right when you need it the most? I'm David with appliancepartspros.com, and today we're going to track down the problem. It could be the circulation motor, a stubborn water inlet valve, a compressor start relay, or maybe the control board is acting up. We're also going to take a look at a few key players like the bin thermistor, the drain pump, the water level sensor, and the cutting grid. Even if you've never tackled appliance repairs before, don't sweat it. This might be simpler than you think. Stick with me and we'll get that ice machine back in business. With over 2 million products in stock and the know-how to help you do it yourself, we are appliancepartspros.com. Let's start by getting our tools together. For today's work, we'll need a 1/4-inch nut driver, a multimeter, a light, a Phillips head screwdriver, and a towel. Also, please remember that safety comes first. Don't forget to unplug your freestanding ice machine or turn the breaker off. The way my brain works, if I can understand how something works, I've got a much better shot at figuring out what's broken. So let's break this down. Water from a reservoir is pumped over a chilled evaporator plate. That plate gradually builds up a sheet of ice, usually around 1/2 inch thick. A temperature sensor underneath monitors that plate. And once it hits that set temperature, it signals the control board to switch modes. The evaporator plate actually reverses roles and becomes a condenser, warming up just enough to release the ice slab onto the cutting grid, which cuts it into those cute little Scrabble squares. The drain pump drains the old water from the reservoir. The inlet valve refills it with fresh water and starts all over again. And once the ice bin starts to fill up, a bin thermistor monitors the ice level and shuts everything down at a certain level, keeping things from overflowing. Pretty neat, huh? The circulation motor's job is to pump water from the reservoir up to the manifold. If the motor isn't running, nothing's flowing over the plate, which means no ice. In most cases, the motor gives you a warning before it fails. You'll hear a squealing noise. That's your clue it's on its way out. Power-wise, the motor is controlled by the board. It doesn't use standard 120 volts. There's a transformer that steps it down to 12 volts AC. If you still got ice in the bin, do yourself a favor. Lay a towel over it. The screws in the ice machine are stainless steel, which means they're not magnetic. Drop one into the ice, good luck finding it. Drop one into the drain at the bottom, even worse. Trust me, I have been there, done that. Now, here's how to get to the circulation motor. Unplug the grid connection along with the bin thermistor. Then remove the screws holding the grid in place and slide it out. Plug the bin thermistor back in. The unit will not run with it disconnected. Extreme care should always be taken to protect against electric shock, which could potentially result in serious injury. Please do not test live voltage if you are uncomfortable using a multimeter around live voltage. Now plug the unit back in. Locate the plug powering the circulation motor and disconnect it. Go ahead and start the ice machine. Set your multimeter to AC voltage and check for 12 volts at the 2 terminals. You might need to wait a few seconds for the control to actually call for the motor to run. Don't rush it. If you're getting 12 volts, but the motor's not running, it's toast. You'll need to replace it. If there's no voltage, you're likely dealing with either a broken wire, a failed transformer, or a bad control board. Look carefully at the plugs and connections in this area. If there's a lot of corrosion at the connections, you may need to clean them up or even replace the wire harness if it's bad enough. One of the best tools that you can have in your toolbox is a multimeter, and we'd love to show you how the device works and how you can benefit from using it. Check out the video in the description. If you're not getting any water to go into the water reservoir and you are certain there's water going to the appliance, you may have a bad inlet valve. This model has what is called a smart valve. First, locate the smart valve. It's usually either tucked in the back or up front, most often on the left side near the condenser coils. On this unit, it's in the front. There are 4 screws holding the front panel on. Once they are removed, you will see the valve on the left side. Now remove the 2 screws on the left side that hold the valve in place. Once you've got access, find the black wire and then the white one running into the valve. Leave the power on and make sure the machine is in a fill mode. Now take your reading. You should read 120 volts AC. If that voltage is there and the valve still isn't doing its job, that's your answer. The valve's shot and needs to be replaced. No voltage? More than likely, the board has failed. The bin thermistor is the piece that tells your ice maker when to quit making ice. Basically, it keeps track of how full the bin is. Now, when that thermistor fails, it usually doesn't shut things down like it should. The ice maker just keeps cranking out ice, even to the point where it's spilling onto the floor when you open the door. It's not great. Ever seen your ice maker do this? Drop your story below. To check it, unplug the connector and test the resistance across the 2 pins in the plug. You should get around 10,000 ohms at 77 degrees. Plug the bin thermistor back in. The unit will not run with it disconnected. The cutting grid's job is to slice the ice slab into those nice little Scrabble square cubes. When it stops working, usually because the wire breaks, it won't cut the ice at all. It will be obvious that the wire is broken. We will turn the power back on for this test. If the wires look okay and are not broken, we need to see if the transformer is sending voltage to the grid. Disconnect the grid plug and with your multimeter set to volts AC, check the 2 pins. You should read about 8.4 volts AC. If the voltage is there and the grid will no longer cut the ice, a wire is broken somewhere in the grid. If the voltage is not there, the transformer has failed. The drain pump kicks in to drain the reservoir, flushing out any sediment or minerals that tend to settle at the bottom, keeping things cleaner longer. Locate the plug powering the drain pump and disconnect it. Go ahead and start the ice machine. Set your multimeter to AC voltage and check for 12 volts at the 2 terminals. You might need to wait a few seconds for the control to actually call for the motor to run, but don't rush it. If you're getting 12 volts, but the motor's not running, it's toast. You'll need to replace it. If there's no voltage, you're likely dealing with either a broken wire or a bad control board. Look carefully at the plugs and connections in this area. If there's a lot of corrosion at the connections, you may need to clean them or even replace the wire harness if it's bad enough. The only time we should check a control board is if there is a voltage issue where a certain component is not getting proper voltage. Instead, let me show you how to get to it. First, unplug the unit. There are 4 recessed screws, 2 in the front, 2 in the back. Once those screws are out, the console should drop down. From there, you've got access to the control board and the transformer. The transformer steps down the AC voltage from 120 volts AC to a lower voltage that powers the cutting grid, the circulation pump, and the reservoir drain pump. Usually when it fails, the items dependent on it all fail at the same time. To test the transformer, you can ohm out the windings. Disconnect the black plug and test the connections going back towards the transformer. The primary, white to black, should read between 3.5 and 4.5 ohms. For the secondary windings, yellow to yellow should be 0.11 to 0.14 ohms, and red to red should be 0.14 to 0.18 ohms. If any of those are out by more than 10%, it is time for a new transformer. Want to check voltage instead? Plug the unit back in. Make sure the transformer plug is plugged in. You can check the voltages. 120 volts AC feeds the primary side. The yellow pair should read 8.4 volts AC, and the red pair should read 12.8 volts AC. If the compressor is not running, guess what? It won't make ice. Either it is not getting voltage from the main control board, or the start relay is not working and starting the compressor. It can also be a compressor that has failed. Let's explore all these situations. You will need to pull the ice machine out and check for voltage at the start device. Remove the cardboard cover and using a multimeter set for AC voltage, check for 120 volts at the red wire going into the overload. The ice machine needs to be in a normal run mode to read voltage coming from the control board. If voltage is there, either the start device is bad or the compressor is bad. If there is no voltage present, the control board is bad. You can check the winding of the compressor this way. First, unplug the unit. Remove the relay from the compressor. Set your multimeter to ohms. Check from the common, which is the top pin, to one of the other pins. 1 to 5 ohms would be at the run windings. 3 to 11 would be at the start windings. Next, check from the common to the other pin. You will get 1 to 5 or 3 to 11. Go across the 2 pins at the bottom. You should read between 4 and 16 ohms, the total of the run and start windings. Any reading that shows open or way out of range would indicate a bad compressor. To check the start relay, set your multimeter to continuity and go from the M pin or run to the white wire terminal. You should have continuity. Then check from the S pin to the white wire terminal. You should also have continuity. If you do not have continuity on the S or M, the relay is bad. If both tests are good, then the relay is good. If your compressor windings check out and you have proper voltage at the compressor, you still may have a bad compressor. Next, check each pin to the metal casing of the compressor. If your meter beeps and shows continuity, that means the windings are shorted to ground and that compressor's done. Same goes if your resistance readings are outside of those ranges. In either case, you're looking at a bad compressor that needs replacing. The water level sensor sits inside the water reservoir and it works off temperature, not pressure or a float. As water fills the reservoir, it climbs up the sensor and the sensor tracks the temperature change along its surface. Now, there's no reliable way to test this part with a meter, but we can go over a simple symptom-based check. If the water valve keeps running and overfills the reservoir, or it doesn't fill at all, these are the red flags. In that case, unplug the ice machine, find where the sensor plugs in, and disconnect it. Then plug the machine back in and start a cycle. With the sensor unplugged, the board should default to a timed fill. If it starts working again, that's a strong sign the sensor's bad. I noticed on our ice machine, the ice was starting to overflow and was running out the door. I checked the resistance and the bin thermistor was out of range. Here's how I replaced it. Using a 1/4-inch nut driver, loosen the screw that holds the thermistor to the side of the bin. You do not have to completely remove it. Slip the connector loose and remove the thermistor. Here's the old bin thermistor and here's the new one. If you've already got one, great. If not, you can pick one up at appliancepartspros.com. Slip the new one in place and tighten the screw. Make sure it is pointed in the correct position so it can correctly read the level of the ice. Hold the console in place and secure it with the 4 screws. Install the cutting grid, attach the bin thermistor and grid connection, and remount the valve to the side wall using the 2 screws. Reconnect the plug and you're done. Hope this video helped you troubleshoot your KitchenAid ice machine and get it back to cranking out those ice cubes. If you found a part that needs replacing, head over to appliancepartspros.com. Punch in your model number and order what you need. Most parts ship fast, usually just a couple of days, so you won't be without ice for long. Once your part shows up, check out our install videos to walk you through the fix. And hey, drop a comment below. Let us know how your repair went. It's always good to hear how those jobs turned out. Thanks for watching, and we'll be here for your next do-it-yourself project.